Last time we solved quadratics where you could either use the square root method, you could easy factor it, or you could use a difference of squares. Today we do two methods, complete the square and the quadratic formula, to where these aren't factorable, or very unlikely that they're factorable. So as you can see here, this would probably be a nice one to easy factor because the a value is 1, but see, I can't find two numbers that multiply together to be -3 and add together to be 4. Right? It's just not going to happen. They don't do it, So what we'll do is, like, if the a value is 1, which it was, and the b value is an even number, I'm going to have us complete the square because I think it's a lot faster to do once you get used to it. So how do you complete the square? You take all the stuff with the x's and put it on the left side with a plus blank, and then we got to move this other guy over here, so by adding 3, and we put another plus blank on here. Why? Because we're going to complete the perfect square trinomial in this blank. How do you do that? It's so simple to do. When the a value is 1 and the b value is even, you take half of this b value, which is 2, and square it and put that in the blank right here. So since we add 4 to one side, we got to add 4 to the other side. And now this dude right here is known as a perfect square trinomial. It will always factor to be some sort of quantity squared. What does it factor to be? Square root of the first guy. So this is x squared. The square root of him is x. Square root of the last guy, this is a plus 4. Its square root is 2. And then the sign from the middle comes down. That will equal whatever this adds up to be over here, which is 7. And now this is nice because we've got a quantity squared all by itself on one side of the equal sign. I can use the square root method to solve this, so I'll square root both sides. So you don't have to show this little dude right here, but that's what we're going to do. The square and the square root cancel each other out, so x plus 2 comes down. And just don't forget that you're going to get plus or minus. And since this wasn't factorable, it's pretty darn likely that this isn't going to come out nice. It means it's not factorable. So all we got to do is get x all by itself, so I will subtract 2 from both sides, and I like to put the normal number first and the radical second. So there's that. On homework, they might have you put two answers in, so see the plus or minus, it's -2 plus the square root of 7, and then -2 minus the square root of 7. So you could have the two different answers there, depending on what they want us to do on that homework program. So let's do that again. Why are we completing the square? Well, for one, they told me so in the instructions, but we'll do that when we can't factor if the a value is 1 and the b value is even. So how do we do it? We set them up with blanks. So I'm going to keep all my stuff with my x's in there with a plus blank, and I add all the constants over to the other side. Well, in this case, I guess it's subtract, but put a plus blank. Got to have a blank on both sides. How do you fill in the blank? Half this b value, which is -3, squared, which will be a positive 9. Don't forget that when you square anything, it comes out positive. That's usually pretty good. The weird part is factoring this guy. It's always a quantity squared. So square root of the first guy, x. Square root of the last guy, 3, and the sign from the middle. That's the official way it's supposed to work. The other way that you'll notice is it's always just going to be x and half your b value. That's just going to happen every time. X and half the b value. So if you want to take that little shortcut, cool in the game. Over here, add these up. It's a, -2. That's going to be nasty because when we square root both sides, this will become x minus 3. And then when I square root this, I'm going to have to get an imaginary answer. So I'll have my plus or minus. I'm going to pretend he's a positive. Square root of 2 doesn't come out nice, so he's going to be a square root of 2. And all that you do is you put an I with it. And if you had a normal number, you'd put I last. When you have a radical, I comes first. So you're going to get some imaginary answers on homework today. And then to solve for x, don't forget we got to add 3 over. So 3 plus or minus I square root of 2. If you need to separate those out because that's what homework has, there's two different answers. There's 3 plus I squared root of 2 and 3 minus I squared root of 2. So we'll do that one more time. We're doing that because A is 1 and B is even in this case. And I can't factor it. Like, I can't find two numbers that multiply together to be 40 and add together to be -8. Because, dude, if I could do that, I would factor it. It would be so much easier. So setting them up with a blank, subtracting that 40 over with the plus blank. How do you fill in the blank? Half the b value squared. So that would be -4 squared, which is a 16. And then we will do square root of the first guy, square root of the last guy, sign from the middle, quantity squared, and that should equal -24. Let me add that up. Going to get another imaginary answer because that guy's negative. So x minus 4 equals plus or minus I square roots of 24. And they're probably going to make us simplify the square root of 24. So 4 goes into 24 6 times. And why did I pick 4? Because he's the biggest perfect square that went in there. So that's really 2 square roots of 6. And then the I comes with it. So what we'll do is we'll actually put 2I square roots of 6. That's ugly looking, Mr. Fawn. Still, let's try that again. 2I square roots of 6. It's plus or minus. Equal still there. And the minus 4 is still there. And of course, I got to add 4 over. So x will equal 4 plus or minus 2I square roots of 6. Not sure if they're going to make you simplify the radical on the homework or not, but we'll do it. That's completing the square. Quadratic formula, when do we use that? Okay, we definitely can't factor it, and I don't have the a value being 1. You know, even though the b value is even, you can only complete the square if the a value is 1. So what I like to do is this. I like to figure out who A, B, and C is first. You don't have to do this. I highly recommend it. But to do the quadratic formula, you got to have this equal to 0 first. So you know who A, B, and C is. And then, yes, you got to memorize the quadratic formula. I literally just say it to myself every time I write it. I do the opposite of B. So since B is negative 14, I do 14. Plus or minus the square root of b squared. I got to do 14 squared. I know it's a negative 14, but it's always going to come out positive. So 14 squared is 196. Then I literally just copy the rest. Minus 4 times a times c. I want to see all this, please. It's all underneath this radical, and it's all over 2 times a, which I figured that out ahead of time and get 6. So all I actually computed was these two numbers right here. And then I'm going to calculate what's underneath the radical. So I'm going to let my calculator do the work for me there. I'm going to do 196 minus 4 times 3, and I'm just using parentheses, times negative 35. And I get 616. So what I'm looking for is to rewrite it all over again. 14 plus or minus the square root of 616 all over 6. And we might as well talk about it now. This guy right here has a special name. He's what our next part of the lesson is over. It's called the discriminant. That number underneath the radical is the discriminant. And since that is a positive number, I'm going to get 2 answers back. So I don't know if homework will accept this without reducing the radical or not. In my opinion, when this number is super duper large, you don't need to simplify the square root. But I will show you that 4 goes in there 154 times. So simplifying that, that becomes 14 plus or minus 2 square roots of 154 all over 6. Do you see how I square rooted the 4 and I got this? Then, of course, we've got to check to see if this can reduce. So I have to look at these 3 numbers. I call them the triangle of death. The only way you can reduce the triangle of death is if there's a common factor between all 3 of those, which there is. 2 goes into each one. So this 14 would reduce down to a 7. That 2 becomes a 1, but the square root of 154 is still there, and it's all over 3 because I've reduced each one of those numbers in the triangle of death by a factor of 2. Homework's probably going to make you type them in as 2 separate answers. So here's the first one, it's the plus, and here's the minus one as the second dude in that case. So 2 different answers. Pay attention if they'll let you use the plus or minus or not. But no, we don't punch that in to see what that is as a decimal. He's not very nice. So that's the quadratic formula. So if I do that again, it's got to be equal to 0 first. A equals, B equals, C equals. This is just for my own brain. I've been doing this since I was in 8th grade. I always have to write it out. So now I can do, excuse me, the opposite of B, plus or minus the square root of B squared. That's going to be 81. And like negative 9 squared is 81 minus 4 times A times C all over 2 times A. So again, I've only figured these 2 little dudes out ahead of time. And now I'll clean up my discriminant. So when I punch all that in, 81 minus 4 times 2 times 8, I get 18 plus or minus. I just get a 17 underneath there. I like that. That's a much smaller number, and the square root of 17 does not simplify because I can't find a perfect square that goes into it evenly. So the quadratic formula, when to use it? When you definitely can't factor, when A is not 1 and B is not even, or honestly, if the numbers are just really, really big, like maybe maybe it was factorable, but the numbers are so big, like I don't want to sit there and find two numbers that multiply together to be 325 and add together to be 600. You know, it's just like I don't want to do that. So, all right, let's talk more about the discriminant. In the quadratic formula, it's just this. It's the number underneath the radical. It's that b squared minus 4ac. It has nothing to do with the square root symbol, right? It's just the b squared minus 4ac. So when they ask us to find the discriminant, that's all I got to do is b squared minus 4ac. So b is -9. When I square it, I get 81. Minus 4 times a times c. So do you see, I don't have the square root with it at all. All I'm doing is calculating those dudes out. So I got 81 minus 4 times 2 times -4. Sorry, I hit the wrong button. And I want to see what I get back. I got 113 back. The discriminant is 113. And here's what that means. If we did do the quadratic formula, this 113 is underneath the radical. It gets square rooted. So the question is, how many answers would you get if you square root a positive number? You get 2 answers back. Simpler situations. If you square root 25, you get 5 or -5. If you square root 36, you get 6 or -6. You get the plus or minus. If you square root 113, I know it comes out decimally, but you'll still get 2 answers. You'll get the plus or the minus of it in that case. So that means that there's going to be 2 solutions when you do the quadratic formula on that. So let's practice that again. All we're doing is finding the discriminant. It's b squared minus 4 times a times c. So I'll punch all that stuff in my calculator, and I got 320 back. So, I'm sorry, not 320, but -320. Can't read my own handwriting. Because that is a negative number, you get no real solutions back. So that's what they want us to put, no real solutions. Maybe, just maybe, they might say 2 imaginary solutions, but I doubt it. I think they're keeping it real on this situation. How did I know I got no real solutions? Because that is a negative number, and since it goes underneath the radical in a formula, you can't take the square root of the negative numbers in the real number systems, so that's what happens. And then if we do the last one here, we do b squared, which is 144, minus 4 times a times c. Punch all that guy in. We're going to get a really weird dude, 144 minus 4 times 4 times 9. We're going to get 0 back in that case. And 0 means there's only one solution to that. Because if you take the square root of 0, yes, you can do that. The square root of 0 comes out to be 0. But in the formula, there's the plus or minus in front of it. There's no such thing as plus or minus 0. So that's why there's only one solution. This is the only time you will get one solution, is if the discriminant was 0. Anytime you get a positive discriminant, you're going to have 2 solutions. Anytime you get a negative discriminant, you'll get no real solution. So it all says that up here in this sweet little gray box. You can also tell from a graph what the solutions are and what the discriminant is. So I know this is very hard to read on that piece of paper. It didn't copy off very well, but you're looking for the x-intercepts. So on paper, they're right there. It's hard to read this graph because it didn't copy well, but this is at -3, 0, and this is at 2, 0. The x-intercepts are your solutions. So -3 and 2 are the solutions to this guy. And since that guy crossed the x-axis twice, right, you're going to get 2 solutions. That's it. And that's got a positive discriminant in that case. Anytime you get 2 solutions, 2 real solutions that is, the discriminant is positive. Here, this parabola, where does it touch the x-axis at? Just in one spot, it touches it at 3. I know, again, that's hard to read. It's at 3, but since it only had one solution, that means that the discriminant is the number 0. When the discriminant is 0, you just get one solution back. And on the last one here, it's very tough to see. The x-axis is down here in this case, and this parabola never ever even touched it, right? It did not touch it, so that means there is no real solutions to this. No real solutions because the discriminant was negative. Anytime a parabola never crosses the x-axis, it has no real solutions to it. So it's kind of weird. You haven't dealt with that a lot in your math life. If you have questions on that, come on in and see us. And then real quick little backside right here. I already made the graph for you. A company produces and sells a specific product. The profit function is this guy right here. That's not a highlighter, but that's the profit function for sure. Here's the graph of it in this case. What is the y-intercept and what does it mean? So the y-intercept is right there. That's where that dude crosses the y-axis. It is at negative 16,500. What does it mean? Since this is about a company selling stuff, that's where, when time was 0, this company started $16,500 in the hole. That was their initial costs. How many products did the company have to produce to break even? Right? To break even is when you get 0 for your y value, which is profit, when you have no profit. So those are your x-intercepts right there. So it happened at 30, and it happened at 550. It happens twice. You started down here in the hole, right, and then you started selling stuff, and it's like, hey, we broke even. Then you sold more and more and more and more and more, and then this is where your maximum profit would be. And then if you bought too much of the product or something did way too much, if you had 550 of them, that's way too many, right? So you kind of went back, and then if you kept on buying them, you'd end up going back negative again. So the break even happened twice. My open math is probably only going to want this answer, though, like the smaller amount, because you needed to sell 30 of those guys to break even. And then one last one, the total revenue function for French door refrigerators is given by this, and the cost function is given by this in this case, where cost is measured in dollars. For both functions, the input x is the number of refrigerators produced. They say find the profit function. I'm kind of going to do the work over here, but profit is revenue minus cost. And on our last test, we kind of had a little tough time, some of us did, with the signs of it. You have to take your revenue, which is 550x, and take away your cost. This stuff that I have in this green box, I could care less if you write it down, but why I'm showing it is because many people forgot that they have to distribute this negative through the parentheses. If you just remember what I told you, that you just needed to change all the signs in this cost function. So you change all those guys, and then we can combine some like terms, and I actually put them in standard form. I put the squared stuff first, then I put the constant guy right there, and, excuse me, the stuff with the x's, and then the constant last. So that goes in the box right there for the profit function. And then they say find the number of French door refrigerators to break even. There are two ways to do it. One way is you could graph this guy and do it back here, like where I made a graph of it, and you can figure out where it crosses the x-axis at in that case. So if I did that, I already got it punched in. I know I'm moving real fast, but this is just for your benefit, video people. I punched that guy in. Sorry, I wanted to get here. I punched that guy in, and the hard part about graphing this guy is you got to find the right window. Let me make this large and in charge so you can see it. To find the right window, I have experience. I knew that I needed to go roughly to this, where the x minimum was negative 50 and the x max was 600, and etc. So I made this window nice, and if I hit graph, I make a beautiful graph of this. We'll talk more about how to find a good window, but this is what I care about. So I'm going to graph y equals 0 as the second function. So, because that's what I want to know, where they broke even at, and now I find the intersection of those. So if I do second, calculate, choice 5, that is the intersection tool, first curve, second curve, and then I got to get my cursor closer to this guy over here, so I got to hit this button quite a few times. So if I hit enter, it will tell me it's at 20. And since my open math only wants the smaller amount, I did it all by graphing 20. That was really not that hard, but that's because I knew what window to make this guy. If you don't want to mess with graphing it at all, the other thing you could do is solve this with the quadratic formula. That's kind of the entire point of how to solve quadratics. I did A equals, B equals, C equals, and did the quadratic formula. Crappy part about that is you get some huge numbers. I didn't even calculate 520 squared because it's so big, right? So you get some big numbers, and then you do the plus or minus, and I got both of these guys. And they wanted the smaller amount because that's what they said. My open math will ask for the smaller amount. So 20 refrigerators is what they needed to break even. Woo! I really buzzed through that. If you have questions, that's so normal. So come on in. Let us know if you have any questions. Have a good one.